How the Pakistan Air Force shot down a Rafale with the help of Chinese integrated systems. This powerful statement marks a turning point in modern aerial warfare between two South Asian neighbors. On May 6, 2025, the skies above the contested Indo-Pak border witnessed a historic aerial engagement where the Pakistan Air Force decisively demonstrated its air superiority by shooting down an Indian Air Force Rafale fighter jet. But this was not just a dogfight between two advanced jets. It was a demonstration of how China's cutting-edge integrated military systems elevated Pakistan's aerial capabilities, enabling it to overcome the challenges posed by one of the most sophisticated Western fighters in service today. Today, I'll take you through a detailed analysis of how the PAF achieved this milestone. We'll explore the technical strengths of the Chinese J-10C fighter and its integrated systems, analyze the failures of the Rafale in this engagement, and discuss the broader strategic and geopolitical implications. This story is about technology, tactics, training, and strategic vision coming together to change the face of air combat in South Asia and beyond. The geopolitical and historical context of Indo-Pak aerial rivalry. To fully understand the significance of this aerial engagement, we must first appreciate the long-standing rivalry between India and Pakistan. Since their independence in 1947, these two nations have fought multiple wars, with aerial combat playing a critical role in each. Over the decades, both countries invested heavily in modernizing their air forces. India acquired cutting-edge platforms mainly from the West, France, Russia, and the United States, including the highly advanced Rafale jets. Pakistan, meanwhile, increasingly turned to China for military technology, acquiring the J-10C fighter, equipped with state-of-the-art Chinese AESA radars, avionics, and beyond visual range missiles. This set the stage for a high-stakes aerial duel where technological sophistication, pilot training, and integrated systems would determine air superiority. The Chinese J-10C, a technological marvel and game-changer. Design and engineering excellence. The J-10C represents decades of Chinese aerospace innovation. Developed by Chengdu Aircraft Corporation, it is a single-engine, delta-wing multi-role fighter capable of both air superiority and ground attack missions. Its advanced aerodynamics and composite materials give it high maneuverability and a reduced radar cross-section, crucial for stealth and survivability. Integrated AESA radar. One of the J-10C's biggest advantages is its Type 1475 AESA radar, derived from the Chinese fifth-generation J-20 fighter. This radar can detect, track, and engage targets at long ranges with high precision and is resistant to electronic jamming. Its rapid beam steering allows tracking multiple targets simultaneously without giving away its position, a critical edge in modern aerial combat. Advanced avionics and sensor fusion. The J-10C combines data from its radar, infrared search and track, IRST, sensors, electronic warfare suites, and secure data links into a unified battlefield picture for the pilot. This sensor fusion drastically improves situational awareness and decision-making speed, a force multiplier in fast-paced dogfights. Electronic warfare and countermeasures. Equipped with sophisticated electronic warfare systems, radar warning receivers, jammers, and chaff/flare dispensers, the J-10C can disrupt enemy missile guidance and radar locks. This increases pilot survivability and complicates the enemy's targeting. The PL-15 Beyond Visual Range Missile. The PL-15 missile is a critical component in this success story. Featuring an active radar homing seeker, a range exceeding 150 kilometers, and high agility, the PL-15 can strike targets from extreme distances before they even realize they're under threat. Its advanced guidance system makes evading it extremely difficult, even for agile jets like the Rafale. The Indian Rafale, strengths and shortcomings in the 2025 engagement. Rafale's technological strengths. There's no doubt the Rafale is among the world's most advanced multi-role fighters. It features the RBE-2 AESA radar, integrated electronic warfare systems, and powerful engines allowing high speed and maneuverability. Designed for network-centric warfare, it can connect with other assets through advanced data links. Failures and shortcomings during the engagement. However, in this particular fight, the Rafale fell short for several reasons. Radar limitations and detection failures. Despite its advanced radar, the Rafale couldn't detect the J-10C or the incoming PL-15 missile at long enough range. The Chinese AESA radar's low probability of intercept modes and electronic countermeasures kept the J-10C stealthy. Electronic warfare vulnerabilities. The Rafale's EW suite was overwhelmed by coordinated Chinese-Pakistani electronic attacks. These disrupted Rafale's radar and communications, limiting pilot situational awareness and response capability. Missile defense and evasion failures. The Rafale's missile warning systems and countermeasures failed to detect and evade the PL-15 missile, whose speed, range, and guidance made it nearly impossible to counter once locked on. Pilot training and tactical errors. Despite being skilled, Rafale pilots struggled against PAF's superior tactics, real-time intelligence sharing, and integrated command networks supported by Chinese systems. They were caught off guard by the J-10CS radar and missile advantages. The engagement in detail. Step-by-step tactical analysis. Early detection and targeting. Ground radar networks enhanced by Chinese technology detected the Rafale flights early, allowing PAF controllers to cue their J-10C pilots through secure data links. A stealthy approach and radar jamming. The J-10CS used terrain masking and electronic jamming to avoid detection, while their AESA radar scanned without revealing their position. A missile launch and mid-course guidance. From beyond 100 kilometers, the J-10C pilot fired the PL-15 missile, which used inertial guidance with data link updates to stay on course stealthily. A terminal phase and kill confirmation. In the final seconds, the PL-15's active radar seeker locked onto the Rafale despite evasive maneuvers. The missile's speed and electronic countermeasures overwhelmed the Rafale's defenses, leading to a successful kill. Strategic significance and future implications. This May 6 event showcased the narrowing gap between Chinese and Western aerospace tech and Pakistan's strategic advantage in adopting Chinese integrated systems. It underscores the vital importance of sensor fusion, networked warfare, and next-gen missile tech in modern air combat. For India, it is a wake-up call to enhance its integrated defense systems and pilot training to counter these evolving threats. Globally, the event signals the rise of Chinese military exports challenging Western air power dominance, a shift with far-reaching implications. The PAF's shooting down of the Rafale, powered by Chinese integrated systems, is more than a single aerial kill. It's a milestone that reshapes air combat dynamics in South Asia and illustrates the transformative power of advanced technology, strategic procurement, and training. It stands as a case study for militaries worldwide on the critical role of network systems, electronic warfare, and next-generation missile technology in the modern battlespace.